how do we rationalize this fraction, the denominator? Obviously irrational. So first of all, I'm going to look at this expression and say, if I replace the third root of 3 with x and make it a polynomial, what's going to happen? Right? So first of all, third root of 9 can be written as 9 to the power of 1/3. 9 is 3 to the power of 2, then raised to the power of 1/3. Then, of course, that is equal to 3 to the power of 1/3 raised to the power of 2, just switching the powers. That is the third root of 3 squared. If I replace third root of 3 with x, that will become, so, x squared minus twice of x plus 3. So notice that the third root of 3 may not be a root, but this is my motivation behind to construct such a polynomial. So denote it as f of x, perhaps g of x, because I'm going to denote x cubed minus 3 as f of x. Reason is because I noticed that the third root of 3 happens to be a root of this polynomial. Right? Not a root of this, but a root of that. So I can use Euclidean algorithm to find out the greatest common divisor between these two polynomials, just like integers. Right? The same rules. So first of all, I'm going to use the f of as my dividend, x cubed minus 3, and g as my divisor. So x cubed, x squared minus twice of x plus 3. So if I just multiply, if I say the quotient, first term of the quotient is it x, because x times x squared happens to be x cubed. Happens to be exactly the same as this first term. Right? And I have minus 2 times x squared plus 3x. So first term is gone. So I have twice of x squared minus 3x, then minus 3. Don't forget this term. So now if I just say, if I plus 2, then I can just multiply by x squared. So it becomes still the same thing, twice of x squared minus 4x plus 9. All right, so again, first term is gone. So I have x minus 9. So now the remainder already has a lower degree than the divisor, so I'm good. Right? So this is my remainder, r of x. R is a shorthand. So q, a quotient, q of x, right, shorthand. So this is again my f of x, that is g. Right. Perhaps let me just write. F can be written into the quotient times the divisor plus the remainder. Right. So now I'm going to use my previous divisor as my new dividend, plus 3. And use my previous remainder as my new divisor, Euclidean algorithm. Now, so the x times what equals x squared? X, right? So x squared minus 9x, 7x plus 3. X times 7 equals 7x, right? Minus 63. I'm left with 66. Okay? My new remainder, R1. And this is my G. Right? That is the remainder, R, previous remainder. This is the new quotient, Q1 of x. Again, let me just rewrite it into the G. Dividend can be written into the quotient times the divisor plus the remainder, 66. Now that I can isolate 66 into G minus Q1R. What is that? Remember, R can be isolated into F minus Q times G, right? So that is equal to G minus Q1 times F minus Q times G. Just shorthand, G of X, and so on, and so forth. So that is equal to minus Q1 times F plus, let me just factor out G. So I have 1 plus Q1 times Q, quantity times G. Right? What is minus Q1? It's minus of X plus 7. Right? So that is equal to minus X plus 7 times F is X cubed minus 3, right? Plus, what is Q1 times Q? Q1 times Q, still a polynomial, right? That is X squared, 7X, 2X, 9X. 2 times 7, 14, 14 plus 1, 15, times G, right? G is this, X squared minus 2X plus 3. That is equal to 66, right? So which tells me that 66 can be written, if I replace X with third root of 3, like I said, third root of 3 is obviously a root of this polynomial. Right? So this will automatically turn into 0. So again, replace X with third root of 3, X squared. Maybe I can write it into the third root of 9, right? Because there's square outside, so distribute square onto 3, I have 9. 9, the third root, right? Same thing. Plus 9 times the third root of 3, plus 15. Again, times, same thing, the third root of 9. Minus twice of the third root of 3 plus 3, right? So this is my original denominator. Yes. So which tells me that if I multiply my denominator by some other irrational, that'll give me some rational. Right? So which means my original fraction can be written into, after I multiply the denominator by this, it'll turn into this. So I have this, 66 on the bottom. So on the top, like I said, multiply by the same thing, that is this number, right? Third root of 9. Plus 9 times the third root of 3 plus 15.